Yes.
Okay, good. Thank you. All right. So rather than completely jumping in again, my name is Quincey Koziol. I'm a principal engineer at NVIDIA. I'm a long time contributor and participant in the HDF5 community. And today I'm going to talk about the other half of, I think, our roadmap for this year at NVIDIA, and that's to start tackling the cloud and object native, really native. Um, I'll talk a little bit about where we're at now, and I think we could move from there. That's mainly my goal. Nothing negative about where we're at. We can just go forward. So today's HDF5, by and large, um, was built and optimized for high-speed POSIX oriented file systems. It's a self-describing, very sequentially laid out data format, generally in a single file. Um, we created a ton of custom data structures, particularly for the metadata, B trees and heaps and all kinds of crazy stuff. And then we store the raw data set elements in blocks and stuff in the file chunks and things. This is not new. So when Parallel came along, it was very early enough in the history, the evolution of HDF5, we compensated pretty quickly. And that was one of the goals of the labs, the Department of Energy labs here in the United States, kind of funding our initial effort was, yes, we really want you to get to parallel quickly. And so we did that, right? We do have this caveat that was kind of built into the early supercomputers that we were running on, where we require the applications to modify metadata in the file collectively across all the processes. But when cloud computing came along, we were very busy on HPC stuff, and we basically kind of avoided it for a number of years. Um, and thought, oh, I don't know if that's going to take off. We're super busy. How do we get some funding to address this? And just didn't get enough traction in there. Today, as John has undoubtedly talked about, um, there are things that tackle cloud computing for HDF5, not just these, but other ones beyond these. These are sort of the first person contributions from the HDF group. Um, and these start solving problems, and they're good. But I think we could go further. I think we could take these solutions and build them on into a really very native cloud oriented, object oriented version of HDF5. And to kind of use it as a comparison, we'll compare it initially here against Czar, right? Czar came along about 2015, so HDF5 was already 20 years old by that point. Um, but it came along with a really chunked first data set storage mindset, right? It used the storage system to index its data sets because, why not? There's already excellent B trees and stuff in the file systems of today and cloud systems of the world. Um, and it changed how HDF5 had done metadata, right? It brought more centralized metadata perspective, not completely centralized, but more centralized into its format effectively. So, like I say, it's chunked first. Primarily, the chunks are stored as a separate file or object, and that's what object storage systems are really good at. And I worked at Amazon, and they care a lot about the S3 latency. Man, they will go to a lot of effort to reduce their hash table times and try to get things back to you very quickly. Give those deliveries to you. Um, that offloading that onto the file system or the object storage entirely eliminated an entire category of metadata stuff that we wrote and had to maintain and build and optimize and cache in HDF5. They don't have B trees, right? They never needed to build them. They just used what was there. And they algorithmically compute things. They don't have to lookups and those sorts of things. They just know exactly the name, what the chunk is supposed to be, and they go get it from the file system. And when they centralize the metadata, right, they put the critical metadata in a single thing. You don't have to chase an object header in an HDF5 file through a B tree to find the object header and then go look it up in, linked list form inside the file, chasing it all down. It's all in one place. All the attributes are in place. You can get it in a single nice I/O operation and offload a bunch of the other pieces of the metadata onto the file system again. We use naming conventions, and names of groups became the same thing as directories in your file system or bucket hierarchies, sub-buckets. So again, you can offload a tremendous amount more metadata out of your storage system and focus on what's really important, delivering good performance, right? So how do we rebase HDF5 for the win, right? What are we going to go for here? I think we need to focus on, we got to stay with POSIX. POSIX may never go away. I would like it if it did, but it's got some advantages and fine. But object stores and cloud storage is this kind of subcategory of object stores, right? We got to hit all three of these. These all exist today, and they are super popular. If we don't hit them, we're going to fade away out of this realm into legacy style stuff. We got to engage this. Really, really need to keep our programming API and the data model, the idea that our format is self-describing. And, you know, if we can't do scalable I/O, why are we here, right? This is one of the foundational bits of HDF5. We can totally ditch our metadata in combining it all into the same file as the metadata, or sorry, as the raw data. And all these custom file data structures, by and large, can go away. Do you think we need to add in that sharding notion to kind of fragment things so that it's easy and more compatible with the object stores? And I'd like to see us move towards a database style for metadata, not what Jazar has, not what we have today, but something new. So this kind of covers it again, but you know, our applications, we need to move them out into this world without requiring them to change, and we can do that with a Vol connector. I'll get into that. Obviously, the data model has to stick around. This is like the reason why HDF5 works today. If it didn't have this data model, it wouldn't be HDF5. Self-describing, scalable I/O, I've mentioned this. I created so much of this, right? It was kind of a bad idea, right? The metadata combined in the same file as raw data, we always toyed with, well, let's put that into two separate files. And we were kind of going down the right direction, but I think we should take it a step further and make it more even so, commit to that, and stop maintaining our own B trees and 3 kinds of heaps and things like that. Let's learn from Czar. This is not a competition. I'm trying to win. I'm just trying to learn from people who've been here before. Let's go learn this, do it well, probably exceed some of their capabilities today. That's fine. But this will be so much more friendly for object stores and cloud storage, right? And the same thing for databases. These have been around for a long while. Let's use them in the right way. They already have page caching and optimized B trees and queries and all kinds of great stuff. Let's go use that. It wasn't there when we started in 95. It's there today. So all that in mind, kind of context for where we're going, what are we really going to do? I think we need to implement what I've been calling bundles and buckets Vol connector for HDF5. And I think this one should be, in the end game, a transparent, completely replacing for users, not as code, but it's for users, the native Vol connector. The application should just load the bundles and buckets connector by default and have everything work for them to be fully compatible with the native format. So that means that we've got to enable transparent access to the native connector. And we do that by either a combo or some very, I don't know what to call this, sort of stackable in a way. Vol connector, where you either pass down, if it's a native file format, we just go, fine, that's great. We'll go do the native Vol connector, that's fine. Otherwise, we go over here and we do sharded storage with the fancy new stuff that's compatible with clouds objects. If we do it this way, I think we can get to the point where our applications won't see anything different. They'll just fire it up and it'll just work. Again, this will be stackable under the existing pass-throughs also, right? So we can layer async, we can layer logging and whatever we need to on top of the BNB connector. It's got to have some pluggability of its own, right? So there's kind of another layer of, well, I need a different database, right, for storing the metadata, or I want to add a new storage layout. I'll get to that. I'd like to do that in a pluggable way so that we don't have to continually upgrade and modify core pieces of the software. Let's make this more modular now. Let's go into the future in a slightly different way. So taking that on a POSIX file system, this is really easy for the library to detect, right? If you give me a name and I look at it and I can tell it's a file name, well, fine, I'm going into the native connector. If I look at it, I can tell it's a directory, then it's a bundle, right? And so the directory and all the contents below it, subfolder, subdirectories, and all the files within that directory, that's a bundle. And we could treat it as if it were a container for HDF5 in this new ball connector. In the cloud, obviously, if you give me a name of something in the cloud, I already kind of know it's got to go into this vol connector because the native one isn't going to go quite the same way. But we've already got a good mechanism for which vol connector should I plug in for this string when you give us a name, and we'll just plug it in there. That's fine. And again, the bucket and all its contents make up the bundle. So we could, in theory, move a directory hierarchy directly into S3 or mount it as its subdirectory, so sort of like Amazon does with its Lustre, and can back it up with S3 buckets underneath. And that all makes a bundle. Within those buckets and bundles, right, sometimes we're going to need some hierarchy. That's useful. And we're going to create directories and use those in similar ways to ZAR, right? But otherwise, if you've got files or objects sitting inside that bucket, it's either a bootstrap file, which we'll talk about, a metadata database, which we, I think, want more than one of, but that's talk, right? Or some form of a data set piece, a shard. So I do like the ZAR notion to make at least the superblock be JSON compatible, right? And HDF5 now, today in the native format, it's this binary thing. It's fine, but users should be able to kind of look at it in a much more straightforward text format and fine. If you want JSON, fine. YAML, I don't care. XML, whatever. But the primary piece here is that users can look at it and they can bootstrap. How do I find the metadata? Is this a SQLite or a DynamoDB container, right? Is the metadata local? Is it remote? Is it Oracle? Whatever. And so these pieces of the metadata, that sub plugin within the bundles and buckets connector, that has to be pluggable too. So sure, I'm going to go grab SQLite as my first one. So I have a single object. I can pull it directly off the object store in a nice single IO operation and use it. But you could implement it with Dynamo, right? And have everything, the whole database be in the cloud, all the chunks be in the cloud, and have a completely cloud native, offloaded, no server required, passive, but native to the cloud form of this kind of HDF5 container. I think there's some arguments, good ones, for sub-containers that's build up a hierarchy over time. It can be dynamic, or it could just be hybrid. Some of that's local, some of that's remote. And I'd like to at least explore the notion that we could build a meta container where there's thousands or millions of underlying HDF5 files, and then you could query against that. It's probably a little out of scope, but at least if we've got some mechanisms in here where you think about something giant as if it were a normal HDF5 container, and then you could perform operations on it. That has some power, I think. It's going to be not your standard metadata database plugin, but I think there's some real power there. And finally, we got to finish designing the schema and the tables and everything else for this. First cut, I think we need a table for links, the whole group hierarchy if you could query that, you'd say, hey, what's in this file? That's great. Let's pull that out. And we don't have to like just in time poke our way down the file system hierarchy or the buckets and try to figure out what are the objects here. We'll know. We'll have the set of links and everything else that's already available to you. Same thing. Let's put the attributes in another table, right? We'll key look up whatever in the database the right way so that we know which attributes go with what objects in the file, and put the raw data in there too, as long as it's fairly small. Fine, we're going to have to offload big ones, just like we do today. And the same thing for the metadata for the objects. Do you want to know how many three-dimensional data sets are in this file? Well, go do the query against the metadata. You can get that. The raw data, once again, still going to be offloaded the same way we do today. Data sets. This is ZAR in a lot of ways, right? ZAR++, I don't care. Whatever you want to think of it is. Got to be able to handle our typical chunking. In the default case, that looks like a single chunk, a contiguous thing. Fine, that's all right. I'd like to be able to aggregate a lot of small data sets so we don't have to, make 50,000 IO calls to go pull in something that users have created that's kind of small. We've seen that use case for finance data sets in the past where 1 million data sets got created, all of which had a single tick at the top that said no change. And we'd like to be able to accommodate that in a nice scalable way. Let's go do that. Subfiling would be so much better. We could shard by data type, columns, instead of a data space, maybe both. Sparse, hierarchical chunking, irregular chunks, all these sorts of things. But gotta make this pluggable, I think. Putting the smarts inside the main HDF5 library, or even inside the main buckets and bundles vol connector is too much overhead. We've got to distribute this. We've got to open this to the community. We've got to make adding a new layout easy and allow for a distributed, innovative culture to come up here and say, oh, I invented a fancy new layout thing. I can plug it right directly into this new vol connector and people get that benefit and we don't have to make changes directly. We'll talk about the vol connector toolkit piece later, but there's pieces of this, I think, that many plugin authors or even vol connector authors are going to want, and we should take a reasonable, flexible cache and make it be part of the toolkit. If you want something more specialized, great, that's fine, you should go implement it, but we should have something that's part of the toolkit I'll talk about to handle these kinds of new layouts, new storage mechanisms. I'm already almost at time. And I do think that these kind of data set storage things need some way to store variable size stuff efficiently, right? So let's let them reach over and talk to the metadata database plugin also. We got to have strings, stuff like that. So eventually, and I was kind of alluding to this, take the native connector out of HDF5's distribution, make it a standalone, separate native vol connector thing, right? And we're going to have to pull tremendous amounts of the stuff out of the library, the metadata cache, the IO pipeline, all kinds of stuff, and either put it there or move it into this toolkit I'm talking about, where many connectors are going to need these kind of resources. We've got good tested code. It's really, really powerful and very stable. Let's keep it and put it out there for our authors, for our developers, to continue that trend we've currently got on developer API routines. Why are we not advancing? There. So I think what we have today is with a single library should end up with 3 libraries, right? All the non-vol stuff that doesn't operate on data goes in one place. Whether we ship this as 3 libraries, but it's kind of conceptually 3 libraries, right? All the I's and the errors and the property list and stuff like that doesn't touch raw data. And then some efficient toolkit APIs for the actual, hey, I'm making a new plugin of some sort, a vol connector, a plugin for this B&B connector, whatever. Put that in one place. The toolkit for authors. It's not for applications. And then take the native vol connector out. I'm going fast. Sorry. I showed this slide yesterday about performance, and there's some really big numbers in here, and I kind of wanted to talk about how I got to them. So if you've got a couple of minutes, that's where I'd like to wind up on my slides. I think kind of mostly because our performance today is so terrible in these places, we can get easy 100, maybe more X improvements on our performance against object stores today. So I yanked this performance study out of this paper, cited it here. And basically what they're doing is comparing 3 tiled, chunked packages, ZAR, TIFF, which does tiles, and HDF5 chunked, right? And the top row is what's the baseline speed of light for if you could extract maximum performance out of whatever their storage system is. And so the green one is a local file system, orange is a local object store, and then blue is reaching out to the cloud over some S3 connection, which you can get into the paper and talk about what their environment is like. So this first, I'm going to ignore TIFF. I'm not worried about it. But this first one, ZAR is very comparable between its file system and its local object store performance, right? They're really demonstrating that you can achieve pretty darn good performance compared to POSIX against the local object store. Yes, S3 is over there, but that's mostly just the latency gap getting over to the S3, itself. So HDF5, we're faster than ZAR if it's a local file system, but boy, we're just terrible. 100x slower for a local object store, 1000x slower if you go into S3 and you're just doing a normal HDF5 file. So this is why I think we can pull these bars, the orange and blue ones for HDF5, so far to the left. Easy 100x, maybe more. We could, if ZAR can achieve comparable, not equal, but comparable performance between local object stores and its POSIX performance, I see no reason why HDF5 should not be able to do the same thing. And if that's the case, we'll have even better performance than ZAR against local object stores and S3. We're going to pull both of our orange and blue bars orders of magnitude, 2 orders of magnitude or more to the left on this. We should be able to easily pull these down close, won't be the same, close to our POSIX file system IO performance. If ZAR can do it, we can do it. It's just software. So I'm a little over time. I'm at least at time. I can end here, take questions, talk.
Okay, thank you, Quincey. Let's
Sure.
give a round of applause.
Sure. Any questions or thoughts?
Yes, we have questions. Thomas.
Great.
Hi, Quincey. Thomas Claufer.
Hey.
I love your idea. Like the new file format with JSON metadata or database-based metadata or everything would be vastly easier to use from another language without going through the C library with
yes.
all of the parsing you describe.
Yeah.
But what you're describing is a new file format. Like
100%.
Why rip out
Absolutely.
the core of HDF5 to call this HDF5? Why not call your new thing HDF6? Like it's
well, naming aside, right? That gets into.
But why not do it as a new thing and leave?
It is a new thing.
F5?
It is totally a new thing. It's this connector.
Right. I guess more seriously, my question is like you are layering. It seems to me you're layering sort of more and more vol connectors and pluggable abstraction points for databases and things in like. Why should this not just be a new project within the general sort of HDF?
No, it is. I'm not saying it's this goes into the base distro. This is its own vol connector.
But why not its own whole library?
Well, because the APIs, I strongly believe that the APIs have to remain stable, that the apps need to be able to continue with their, I don't even have to relink. Right. So we've got I don't know what, millions of applications that call into HDF5, including the ones that come in through layers on top of us, like NetCDF and whatnot. Having that API is powerful. That's incredibly valuable. We cannot move away from that.
Quincey, thank you for your talk, and I completely agree with Thomas that it's kind of new thing. But let me just comment about a few things. First of all, I would not dismiss HDF5 file format if you look at a little bit, step back and look at it. So what it stores in linear space, which is, yeah, POSIX space, fine, but it stores pointers in linear space to the objects or to pieces of objects and information, and also data structures, linearized data structures that help library to do efficient, retrieval and so on. Nothing prevents us to expand HDF5 format. Still, it is whatever it is, but instead of using 64-bit pointers, have just identifiers that point to the objects over internet, on different storages, whatever it is, and expand notion of container not to be on the local system, but further down. And it will not require any wall connectors. You probably will need VFDs, which much easier to implement. With this wall approach, you're throwing away or have to implement a lot of good things that are available in the library. And I'm not saying this is bad, absolutely not. I'm talking from perspective of HDF5, kind of protecting our baby from you're throwing away cache and many good things and features that are already available in the library. So while having wall connector, it's a good thing. We still can do a lot of in HDF5 to improve performance. Also, I will not buy into these numbers that you showed because, for example, Alexander showed that if you use page deallocation and modified read-only S3, performance as good as ZAR. And there are many ways.
I mean, it's going to be about an order of magnitude better than ZAR.
So until we can run this experiment and see how it was taken, I would not completely agree, because in recent years there were a lot of improvements in accessing object store. And then you can do with VFDs a lot of things that really create object store kind of storage with the native library, native features, and use it through VFDs. So I would be very careful in this.
I totally am open to the discussion. I
Okay.
disagree, but it's a good discussion to have.
So it is interesting. So what are your plans in implementing this? When it will be available, at least as prototype?
I believe, and you can tell from this one, I've got less details about coding stuff. This is probably going to get started later this year. I got to get the accelerator native stuff started first. So I'll get started on that over the summer, I'm guessing, and have some fall interns come into it. And so this will be later this year, I'm guessing. We'll see how it goes.
You were right about multi-threading for times. I showed today graphs. I don't think you were able to see my presentation.
No, I wasn't getting up at 4:30 in the morning.
But we did see very nice scaling with our multi-threaded wall connector and with updated multi-threaded modules. So a multi-thread is the way to accelerate for sure.
So I think we'll have to continue this discussion at some later point in time. It's very interesting. I appreciate your time, Quincey. And now it's time to move on to our next session. Let's give one more round of applause for Quincey.
Thank you.
Yeah, thank
so
you.
Maybe you can take a question from Mark. He was holding his
Sorry,
hand.
Mark, I didn't see you. Go ahead.
Sure.
Well, I think this is really exciting, Quincey. I think we talked about the OMEN GFF stat. I'm going to point out that's now 4 or 5 years old. And there have been, right. But I think just pointing out that there have been massive improvements on the SAR side as well, in many ways. And there's, I think I was still comparing against the Python library as well. And there's now, as you know, C implementation, C++ implementation by Google. but I think, this way of kind of making things more pluggable, allowing for alternate kind of wall connectors, alternate formats will really allow for innovation on the backside, which I think is really critically important for us as this thing computing starts to change. So I'm really glad to see that. Kind of just maybe responding to Thomas's comment earlier. I think there's really three different aspects of HDF5, right? There's a file format, there's an API, and then there's a library itself. And I think we need to be able to slightly start separating those out a little bit so we can start innovating in all three, right? I think we can keep the API stable so that programs still continue to work, but innovate on the backside. And I'm really glad to see that in your work. So, yeah, I'm excited to see where this goes. Thank you.
Sure. Thanks, Mark. Yeah, I agree.
All right. Okay. Awesome. Thank you very much.